Good day to you all. Welcome to the sixth lecture of ship's magnetic compass. In this lecture, we learn about ship's magnetism, ship's paramagnetism, and different components of ship's paramagnetism, which include P, Q, and R force. Let's begin. Before starting about ship's uh, reasons of ship's paramagnetism, we need to know about reasons of ship's magnetism itself. There are different reasons for which the ships attain magnetism. The first reason of having magnetism on board ship is made of a ferromagnetic material. That means ships is made of steel, iron, and other magnetic material which is subject to induction of Earth's magnetism. Beside that, ship is made with modular construction. That means different parts of the ship is built in different parts of the world. Let's take an example. Suppose you have ordered a ship in China. The China will not build all the parts of the ship. The ship's hull may be built by the Koreans, whereas the ship's accommodation will be built by Japanese, and ship's engine will be built by Germany. And once all the parts of the ships are being built, then those parts will be exported to China, and China will weld those parts, and finally the ship will be delivered to the customer. So as different parts of the world is building different parts of the ship, therefore the ship will have a resultant magnetism in itself. And during this construction of the ship will lie continuously in Earth's magnetic field. As different parts of the ship is being built in different parts of the world, so different parts will have different magnetism. Therefore, it will impact the compass needle different way. In addition to that, while the ship different parts was being built, that time those parts will be subject to hammering, heating, and welding, which will create magnetism automatically. And during those hammering and heating process, the ship will be affected by Earth's H force and Z force, which will create magnetism on the ship. So we can see that the ship, due to its construction process, will gain some magnetism. So the ship's magnetism we can divide in two distinct categories. One is permanent magnetism, another one is induced magnetism. What is permanent magnetism? Permanent magnetism is a magnetism where the magnet retain its magnetic property once you take that magnet from the magnetic field, whereas the induced magnetism, it doesn't retain any magnetic property once you take out the induced magnet from the magnetic field. Here you can see that is a magnetic bar which is a permanent magnet. So wherever you keep in the world, that permanent magnet will always face towards the North Pole, and the red points of the paramagnet will face towards the North Pole, whereas here this is a magnetic bar. Due to that magnetic bar, these James clips are being induced, but if we take out this magnetic bar, the James clip will lose its magnetic property. So that's why this is called induced magnetism. So the magnetic material which is induced by paramagnet, we call them as soft iron, right? And soft iron can only become induced if it is aligned with the inducing field, whereas hard iron retain is all the magnetic properties and magnetism in all heading. So thus in induced magnetism, the ship's heading plays a vital role, and due to different heading of the ship, the induced magnet will have different pole. We will discuss this matter later on in another lecture. Just I'm just giving you a heads up. So as per previous slide, we can say that the hard iron is susceptible to the permanent magnetism, and these hard iron we call them as low permeability magnetic material, whereas the soft iron is susceptible to induced magnetism, and these soft iron is being called as high permeability magnetic material. Before going to more in depth, we need to remember an important note. What is that note? You can write it down. At the compass position, there will be a resultant magnetic field due to both permanent and temporary magnetism, which will cause the compass needle to be deviated from the magnetic meridian. And this is a very important note, and I want you write it down in your notebook. Let us see the components of permanent magnetism. At the ship's compass position, that part of the ship's total magnetism which is considered as permanent magnetism is resolved into three components, namely fore and aft component, athwart ship component, and vertical component. Let's draw a shape. So it is a shape. So that shape has, as it is a three-dimensional object, it will have three components. The first component, which will run fore and aft direction, we call it as fore and aft component, or ship's P force, right? The component which run on athwart ship direction, we call it ship's athwart ship component, and the component which run on the vertical direction, we call it as ship's vertical component, or ship's R force. When the ship is stable and it is not heeled or listed to any direction, then that ship's R force will not have any impact on the ship's magnetic compass, whereas the fore and aft component and athwart ship component will always have some impact on the ship's magnetic compass. Now if we keep a compass needle, then the ship compass needle will always face towards Earth's magnetic north. But if you have a red pole beside the ship's compass needle, what will have? It will have some impact. Let us see what impact it will have. Suppose our ship has got a blue pole just beside the compass needle, then this, due to that blue pole, the compass needle will be attracted, and it will be deviated towards the blue pole like that, right? On the other hand, if you have got a red pole beside the compass needle, due to that red pole, that compass needle will be deflected, and it will have some deviation on the opposite side, right? So this concept is very important to understand the ship's P, Q, and R force, because this concept will apply to find the different P, Q, and R force. Let's see how we get different P, Q, and R force. So here we have got two ships, and we know that ship's 4.5 component of the ship's paramagnetism is referred to as P force. Now, if while construction the ship has a blue pole at the forward, then what will happen? That blue pole will attract the compass needle, and the compass needle will feel an attraction towards bow, and it will be slightly deviated towards bow, and those type of ship we call it as plus P ship. Whereas during construction, if the ship creates a red pole on the forward, that ship's compass needle will be deflected by that red pole and attracted by the blue pole of the aft, and it will feel an attraction towards astern, and we call it as a minus P shape, right? In that way, we can categorize two different type of P force. Likewise, we know that the other ship component of the ship's paramagnetism is referred to as Q force, right? So if you have a blue pole on the starboard side and red pole on the port side, what will happen? This compass needle will feel an attraction to the starboard side because of that blue pole, and it will slightly deviate to the starboard, and this type of ship we call as plus Q ship. Whereas if you have got a red pole on the starboard side and blue pole on the port side, that compass needle will be deviated by that red pole and attracted by the blue pole, and it will feel an attraction towards port side, and it will be deviated to the port side, and this type of ship we call it as Q ship. Similarly, we have got vertical. We know that the vertical component of the ship's paramagnetism is referred to as R force, right? Here we have got a ship, and it is in normal condition, and this ship doesn't have any list. So here is my compass needle, and which is on the monkey island. So if during construction at the deck or monkey island or top side of the ship has got blue pole, what will happen? That blue pole will attract the compass needle, and the compass needle will feel an attraction downwards, right? So this type of ship we call it as R shape. However, when the ship is stable, there is no list or heel, that time this type R force will not have any impact. On the other hand, if the ship has a red pole on the top of the ship, that means on the deck or on the monkey island, and blue pole at the keel, the compass needle will feel a deflection upwards, and this type of ship will be termed as minus R ship. However, same like plus R ship, when the ship is fully upright, that time the R force will not have any kind of impact on the compass needle. The R force will only come into action when the ship will be slightly heeled or laced, right? So let us make a table of the effect of this PQR force. So when the blue pole in the bow, the compass needle will have an attraction towards the bow, and those type of shape we call this type of force we call it as plus P force. When the blue pole is in the stern, and the compass needle will have attraction towards the stern, and this type of force we call it as minus P force. When blue pole is on the starboard side, an attraction will be felt by the compass needle towards starboard side, and this type of force we call it as Q force. When below pole is on the port side, an attraction towards port side will be felt by the compass needle. This type of force we call it as minus Q force, and when blue pole is on the deck below the compass we call it plus R force, and when blue pole is on the keel we call it as minus R force. So this table is very important for your future understanding of the magnetic compass. I want you to make a table like that and keep it ready for future classes. Thank you very much.